Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at dividing polynomials. Now, before we start dividing polynomials, we need to know what polynomials actually are. So here is the definition. A polynomial is a finite expression with positive whole number indices. So let me break that down. We have a polynomial, that's the definition. It's a finite expression. So finite means there is a limited number of terms, okay? An expression is just a collection of terms, maybe added or subtracted together, okay? And it's a finite expression, so we only have a finite number of them. There might be 3 terms, there might just be 1 term, there might be 10 terms, okay? We don't have an infinite number of terms, we can count the number of terms that we have. And it's a finite expression with positive whole number indices. Positive, so we don't have any negative powers, okay? And whole number, the whole numbers are the indices, so we can't have a square root, you know, to a power to a half. We can't have a decimal in the indices, they must be whole numbers, okay? So let's have a look at some examples. Here are 3 examples, okay? We have other examples than just these 3, but we've got ax plus b, ax squared plus bx plus c, and ax cubed plus bx squared plus cx plus d, etc. Okay, where a, b, and c and d are real numbers, they're just constants. We can clearly see that those 3 examples are our general linear form, our quadratic form, and our cubic form. Okay, so all of those are polynomials. Things that aren't polynomials, we could maybe do some non-examples. I'll do them in blue here, and I'll just take these from the book. So non-examples are things like I said, the square root of x, because that would be x to the half. So that's no good because they are not whole number indices. We've got a power of a half. We've also got 6x to the minus 2. That is no good because we have a power that is negative. Even though we can write that as 6 over x squared, even though we have a positive power there, we can write it as a negative power, so that's no good, okay? And there's loads of other examples as well. We could maybe have 4 over x, okay? That's not a polynomial because 4 to the x minus 1, there's a negative power, and we just want positive powers, okay? So those are 3 non-examples, these are 3 examples. Now, we can use long division here to divide polynomials by a factor. And we use long division to divide polynomials by this factor here, where p is a constant, x plus or minus p. And I always write brackets around it here because that's what we divide by. We divide by all of it. We divide by x plus or minus, it might be x plus p, so x plus 2 maybe, or it could be x minus p. P could be maybe 4, so x minus 4, for example. Okay, so that's where we use long division. Now, there's 2 types of long division. You can either do it normally, like in a bus stop, okay, and do the long division that way. Or, a way that I prefer is to use a grid. And I'm going to do 2 examples in this video so that we can show off both of the methods. So, let's have a look at where we start. The first example, we're just going to do normal long division. You might have seen this before. It took me a while to get used to this long division because I definitely prefer the grid, but we'll do an example like this to start with. So, we have 2 polynomials here. We have a cubic, and we have the factor that we are dividing by. So like I said, we divide by x plus or minus p. Here we have a negative, and our p is 3. So what we're being asked to do is we're being asked to divide this cubic, x cubed plus 2x squared minus 17x plus 6 by x minus 3. And we'll do that using long division. So, if you already know how to do this, have a go, see what you can do, and then press play. To start off the solution, what we're going to do is we're going to write what we are dividing by outside of our little bus stop or our long division lines. So, the x minus 3 goes here, and then what we are dividing goes under the lines. So we're dividing x cubed plus 2x squared minus 17x plus 6. So that is going to go there. Okay. And then what we're going to do is we're going to take each term and we're going to deal with each term separately, okay? So we're going to start with x cubed. And what we do is we divide x cubed by x, okay? And we're going to write that, x cubed divided by x is x squared. We're going to write that on top of the line. So that is my first term, okay? Then what we're going to do is we're going to take the x squared term and we're going to multiply it by this bracket here, okay? So what we've done so far is we have took x squared and we've divided that by x, okay? Then we take x squared, because that's what x cubed divided by x is, we write that on top of the line. This in grey here, these terms, we're going to have more terms in a minute, but those terms that appear on that grey line, okay, at the top of the lines, is your answer. That is what you get when you divide. So we're going to get some more terms, okay? So we've took the x cubed, we divided by x to give the x squared, and then we multiply the x squared by everything inside the bracket, and we write it here. So x squared times x gives me x cubed, and then x squared times minus 3x gives me minus 3x squared, okay? Right, that's quite simple. We write it like that, and now what we do is we subtract what we have here, these first two terms, the things that match up, we subtract these two terms from the first two terms in the term under the lines. So what I like to do is I like to put a bracket there because I'm subtracting, okay? So I'm going to subtract from what's under the lines these two terms, okay? So if we write a little line like that to kind of show we're doing a subtraction, and this is what we're going to get. We're going to get x cubed plus 2x squared minus x cubed minus 3x squared. The x cubes are going to cancel. We're going to get 2x squared plus 3x squared, okay? Because it's a negative and a negative, so 2 plus 3 is 5. That gives us 5x squared. We are then going to carry down this third term. So this third term will carry down to there, okay? And I'll make that arrow a bit better. There we go. So we'll carry that third term down, minus 17x. Then what I'm going to do is I'm going to take the first term here and I'm going to divide that by x again, just like we started with this first term. So the second term divided by x, this 5x squared divided by x, is going to give me a positive 5. And I will write that as my second term up there, okay? Then what I'll do is I'll kind of repeat the pattern. We then multiplied x cubed by everything inside the bracket. We've already done x cubed, not x squared, sorry. So we'll now do 5x with everything inside the bracket. So when we do that, I'll get this, and we're going to write it under here. 5x times x gives me x squared, and 5x times minus 3 gives me minus 15x. And then, just like we did, we're going to put brackets around it here and subtract from these two terms. So let's do that. We'll subtract from these two terms here. So we're going to have 5x squared minus 17x minus 5x squared minus 15x. The minus and the minus is going to make a plus. So we're doing a subtraction, so we'll do a little line across there. The 5x squareds are going to cancel, and we're going to be left with minus 17x plus 15x. That's going to give me minus 2x. Okay, so that's all we can do then. We are then going to bring the 6 down like that, carry the 6 down to give me a plus 6, and I am then going to kind of start the process again, okay? I now have two terms that I'm dealing with. I'm going to divide this term by x, just like we did with the x cubed and with the 5x squared. We divided by x here, in fact we use a different colour. We divided by x there and on that term as well to give us these terms, okay? So divide the minus 2x by the x, and we'll place that at the top, will give me minus 2, okay? So hopefully that makes some sense there. Then what I'm going to do is I'm going to multiply the minus 2 by everything inside the bracket, and I'm going to write that underneath here. So the minus 2 times the x gives me minus 2x, and the minus 2 times the minus 3 will give me a positive 6. Then, hopefully, you can see what I'm going to do now. I'm going to subtract that from these two terms. So let's do that. We're going to have minus 2x minus 2x. That will give me minus 2x plus 2x will give me 0. And then we're going to have 6 minus 6 will also give me 0. So that is where I stop. I am now at a 0 term, if you like. This term here is 0. Now what that means is we have a remainder of 0, because we've now got to the point, if we look how all of these have kind of lined up, here was my x cubes, here was my x squareds, here was my x's, and then here was my constants, okay? We could see here's all got x's in there in that row. In this row here, they're all constants. The final constant is 0, so that means we have a remainder of 0. Let me write that down. Hopefully you remember what a remainder is. Because we have a remainder of 0, it means x minus 3 goes into this cubic perfectly. We don't have a remainder of 1, we don't have a remainder of 10, I don't know, there's just some examples. We have no remainder. So that means this factor, x minus 3, goes into the cubic perfectly. Okay, so what is my answer? It's everything that is under this grey highlight, okay? This is the answer. So it's always nice when you do a question like this to say, therefore, x cubed plus 2x squared minus 17x plus 6 divided by x minus 3. You don't have to put brackets on the x minus 3 there, it's totally up to you. Is equal to everything on the top there, x squared plus 5x minus 2, okay? That's our answer, but we also call that the quotient, okay? That is the quotient. In fact, we'll write that in orange, okay? That is the quotient. Okay, so that's all we really have to do in terms of long division there. It's pretty repetitive. You do the same thing for each term. So a little overlap, we took the x cubed, we divided it by x to give us x squared, we multiplied the x squared by everything inside the bracket, and we took it away. We then got the 5x squared, we divided it by x to give me the 5x, we then multiplied all of that by whatever is inside the bracket, and we then took that away. Be careful of double negatives. Then we got minus 2x from the subtraction here, and then we divided that by x to give me the minus 2 in my answer, and then we multiplied the minus 2 by everything inside the bracket. And then once we did that, we did the substitution again, and in our kind of constant row here, we ended up with 0, so it's a remainder of 0. If we ended up with a 1 there, like I said, we would have had a remainder of 1. So whenever you end up with no x terms when you've done a substitution, that is what your remainder is, okay? Makes sense there. We've got rid of all the x's, nothing more we can do with a constant, so that must be our remainder. And then we can write it like that. It's nice to kind of summarise what you've done, because this really doesn't mean much. This is just a method, okay? It's like doing a method question and then not writing your answer on the answer line. This is just a method, and it doesn't really mean that much without some explanation. So explain at the end that this is your answer. Okay, I'm now going to do the exact same question, but I'm going to do it using the grid method. So it is actually a form of long division. It's not the known long division like that one is, the method that I've just done, but this is what I find a little bit easier. So we can see we have a grid here, and we do more or less not the exact same thing, but we do a similar thing. So what we do is we write what we are dividing by on the left-hand side. We're dividing by x minus 3. So what we do is we split it up and we write x and minus 3, okay? That's what we do there. If you were dividing by something like 2x plus 6, then you would have 2x, and that would be a plus 6, okay? But we don't, we just have x minus 3, so we'll leave it like that. Then what we do is we go term by term along what we are dividing, okay? We're dividing this cubic, so we're going to go term by term. We write the first term here on line with the x. And we think, if I put a little multiplication symbol there, it's like a multiplication grid. And we say, okay, what do I need to multiply x by to give me x cubed? What goes on here is kind of like our answer to the product of x and whatever I'm going to put here. So x times something gives me x cubed. It kind of works like that, okay? So what am I going to have that something to be? Well, whatever we multiply x by to give me x cubed, that's x squared. So x squared is going to go there. And now we can just see that we're just going to multiply here. Minus 3 times x squared, if we look at that in grey again, is going to go there. Okay? So what is that? Well, minus 3 times x squared is just minus 3x squared. Okay, we are then going to now go back and look at the x squared terms. We have finished the x squared terms here, or finished with the x squared terms. So we then need to think in our answer, or not our answer, in our question, what we're dealing with is 2x squareds. At the minute, I have minus 3x squareds. I don't want minus 3x squareds, I want 2x squareds. So we kind of are going to work along a diagonal here to think, what do I need to add or subtract? In this case, it's add. What do I need to add to minus 3x squared to give me the number of x squareds that I need, which is 2. I need to add 5. So I'm going to add on 5x squared. Okay, hopefully that makes sense. You can see now what I'm trying to do with all of these terms that I'm going to write under these lines. They're all going to add together to give me what we're dividing. Okay, so minus 3x squared, working along the diagonal, plus 5x squared gives me 2x squared. And then we can just think, looking along here, what do I need to multiply x by to give me 5x squared? Well, that's quite easy. That is just 5x. We can just divide 5x squared by x to give me a positive 5x. And then we can do a little bit of multiplication. I'm going to just get rid of that line to make it a little bit easier to see. We're going to do some multiplication. So 5x multiplied by the minus 3 gives me minus 15x. And just like we had to work along the diagonal here with the x squareds, we need to work along the diagonal here with the x's, okay? How many x's do I have in what we're dividing? Well, in the question, we have minus 17x. So here, I have minus 15x. I don't want minus 15, I want minus 17, so I need to I need to take 2 off. Make sure you get your signs right, okay? I need to take 2 off because minus 15x minus 2x gives me the minus 17x that I need. Now, we can again think, what do I need to multiply x by to give me minus 2x? What's going to go here? That is going to be minus 2, because minus 2 multiplied by x gives me minus 2x. Okay? Right, then we can do some multiplication again. We can say the minus 2x and the minus 3, sorry, not minus 2x, the minus 2 and the minus 3 multiply gives me a positive 6. Just like we did here, we have now come across a constant term, so I cannot do anything else. So to work out the remainder here, we look at the constant term. I will highlight that in a different colour. I'll do that in purple. We look at the constant term and we compare it with the constant term in the question. They are the same here, so what I always do is I do a dashed line like that, and I say remainder is clearly 0 because the constant terms add up, or the constant terms are the same. Okay, that's how we tell whether there's a remainder of 0. If the constant terms were not the same, so say for example, and I'll do this in red, the constant term was a +1, I don't want the constant term to be a +1, I want it to be a +6. So again, we kind of need to work along the diagonal to see what we need to add. And we need to add, I'm going to have to rub that out a minute. We need to add along the diagonal to give me a +6. I'm going to need to add 5. So there we'd have a remainder of 5, okay? That was just an example. It worked really nicely, this question, of course, because we knew from the other question that we have a remainder of 0. So what is our answer? Well, we know the answer. The answer is what lies on the top of the grid there. So again, I would quite happily do this, and I'll duplicate that. It makes your answer quite neat and finished, and it's more important actually with this method to do a little summary, because that just looks like a grid with some terms in. You must make sure you put this at the end. Okay, let's have a look at another example. So it says f of x is equal to 4x to the 4 minus 17x squared plus 4. We want to divide f of x. Remember, this is what f of x is. Divide that by 2x plus 1. And we want to give our answer in the form 2x plus 1 multiplied by some cubic. Okay, so pause and have a go. Use either method. We've got 2x plus 1 here being divided into f of x. So think, do you want to do the grid method? Do you want to do the long division general method that you've probably seen before, maybe? And then pause and have a go, see what you can do, and then press play, and we'll work through the answer. Okay, I'm going to do the grid method, and if you do the long division method, you're still going to get the same answer. So if I do grid and you get the right answer, then you know that you have done it correctly. Okay, so the grid method is what I find easier, and I will try and do it quite quickly and not do too much explanation because it's very similar to what we've just done. So what we are doing is we're dividing this by 2x plus 1. So I'm going to have 2x plus 1 on the left hand side. I'm going to put a little multiplication symbol there just to show that actually that's what I'm doing. That's how the grid kind of works with multiplication. So the first term that we have is 4x to the 4. So I'm going to write that there, okay? Then I need to think, what do I multiply 2x by to give me 4x to the 4? That is 2x cubed, okay? In other words, 4x to the 4 divided by 2x. Check that. 2 times 2 gives me the 4. X times the x cubed gives me x to the 4. Then I can do a multiplication there of, and I'm going to just put my sign in, positive 2x cubed. Work along the diagonal. I can see that I have no x cubed terms in my f of x quartic. Sorry, I have no x cubed terms. So I'm going to need to take off my 2x cubed terms along the diagonal. Okay, what do I need to multiply that by? That is going to have to be a negative, and it's going to have to be a negative x squared. I think that's right. Let's double check. That's going to raise the power to 3, and the negative will give me a minus 2. Perfect. Let's do a little bit of multiplication. Minus x cubed, x squared. Okay, I don't have minus 1x squared, I have minus 17, so working along the diagonal, I'm going to need to take off 16x squared. Then when I divide that by 2x, I'm going to have minus 8x. The minus 8 and the 2 will give me the minus 16, and the x times the x will give me x squared. That works perfectly, and along the diagonal they add to give me minus 17. Okay, let's think what we need to do now. So we have now a minus 8 times the plus 1, that's going to give me minus 8 x, okay, and I have no x terms in f of x. This is what we're trying to make here. When we add all of these together, all of these terms that are in the grid, they're wanting to make f of x. So we don't have minus 8x, we have 0x. So I'm going to need to add 8x to kind of match those up perfectly. So what do I need to multiply? Well, 8x divided by 2x is a positive 4, and then do the multiplication of the constants, positive 4. I've now got to my constant term, so I now need to consider my remainder, okay? If we go back to purple, if we compare our remainders, we can clearly see that the remainders are the same, or not remainders, sorry, our constants are the same, so our remainder must be 0. So we will then take what's at the top here as our quotient. That's what we get when we divide. So 4, and I'll write that a bit better, therefore 4x to the 4 minus 17x squared plus 4 divided by, and it's 2x plus 1, is equal to this on the top of the grid here. That, by the way, is an R, just stands for remainder of 0. So that's equal to 2x cubed minus x squared minus 8x plus 4. Okay? Now, we want to give our answer as in the form here, 2x plus 1 multiplied by some cubic. So, how can we do that? Well, all I can do is just multiply up, okay? We want to give our answer as some cubic times 2x plus 1. So basically, we're wanting f of x is equal to something. Look, we've got f of x here, okay? So this is what we get when we divide. This is how we want to give our answer. So all I'm going to do is just multiply up by 2x plus 1. So 4x to the 4 minus 17x squared plus 4x. Remember, that is what f of x is, and that's what it's asking us. Give your answer in the form f of x is equal to a cubic times 2x plus 1. Well, 2x plus 1 is what we get. Multiply both sides by 2x plus 1. We'll do that on both sides. That will kind of cancel out there. And then we'll have the cubic that we've just worked out, which is exactly what we need. So then that is our final answer. Okay, we have f of x here is equal to that, and that's how we needed to give our answer. Okay, so if you did it long division using kind of the bus stop, doesn't matter as long as you get that answer. Okay, I in A-levels always use this method. I thought it was much quicker and easier than doing all the subtraction and stuff. You kind of do the subtraction within the grid, which I think is a little bit neater. Okay, so that's all we have to do. We have one more example for this video, and it's worded a little bit differently, but just do the exact same thing. We want to find the remainder when this cubic, 2x cubed minus 5x squared minus 16x plus 10, is divided by x minus 4. Okay, so find the remainder. This time we're not being asked to work out what the quotient is. We're not being asked to divide this by x minus 4, but you're going to need to do that to find what the remainder is. So press pause and have a go. Use the grid method if you used the long division method in the previous example, or all the way around. Press pause and have a go, and then I'll work through the answer. Okay, I'm going to again use the grid method because I find it much easier. So let's do the grid method together. So I'm going to draw my grid, doesn't really matter how big it's going to be, and we're dividing by x minus 4. So x minus 4, let me just move that like that, okay? So I'm going to start with my first term, and it's going to be 2x cubed. 2x cubed, I'm going to multiply. What do I need to multiply by? I need to multiply by 2x squared, so that 2x squared times x gives me the 2x cubed. Multiply over here then, we'll have minus 8x cubed, and then working along the diagonal I can see I'm going to need to add 3x squared. The reason I'm going to need to add 3x squared is because I need to go from minus 8 to a minus 5. So adding 3 will get me to the minus 5. So then I need to think, what do I need to multiply by? I'm going to need to multiply by, I'll do 3x squared divided by x, a positive 3x, because then when I multiply the 3x and the x together, that will give me the plus 3x squared. Do the multiplication down here, that's going to give me minus 12x, and then working along the diagonal, I can see I don't want minus 12x, I want a positive 16x, so I'm going to need to minus 4x off from the minus 12. So along the diagonal, I can see I have the minus 16 there, okay? Because again, under the grid has to add up to this cubic, the thing that we are dividing. So we have that, and then we'll do the division. What do I need to multiply x by to give me minus 4x? It's going to have to be minus 4. And then do the multiplication, that's going to give me a positive 16. Right, let's get purple back out again because that's what we used for the constants. This is now my constant term. I can't do any more under the grid apart from the remainder. That is my constant term. In what we have in the question, I have a constant term of 10. So clearly the remainder is not 0. If the remainder was 0, then my constant term under the grid would have been the same as the constant term here. It's not. We've got a constant term of 10 in the question, and under the grid here, we've got a constant term of 16. In other words, we don't have the cubic that we want. When we divide this by x minus 4, we get all of these added together, so we get 2x cubed minus 5x squared minus 16x plus 16. I don't want plus 16, I want plus 10. So this is where the remainder will come into it. And again, we're going to work on a diagonal here. So what do I need to add or subtract to 16 to give me the 10? I'm going to need to take off 6. Because then along the diagonal, just like we did with these diagonals here, we get the right constant that we need. The constant being 10. 16 minus 6 gives me the constant that I need. So highlighting that as well will give me the correct constant. So this here is my remainder column. So all we have to do is just read off the remainder. And the remainder, we can say, therefore, the remainder, we weren't asked for the quotient, so we don't need to write this bit down. We don't need to write that bit down, just the remainder, because it said find the remainder. So the remainder of 2x cubed minus 5x squared minus 16x plus 10 divided by, and we're dividing by x minus 4, is minus 6, okay? So hopefully if you did long division, you got minus 6, you would have just ended up with your remainder here, okay? It would have been your final term without any x's left in, and you would have got a minus 6, okay? You would have been left with minus 6 on the bottom, and you would have took minus 4x plus 10, you would have taken away minus 4x plus 16 to give you your remainder of minus 6. So there is the full question. So that minus 6 there is our final answer.